Hey guys, so today we're going to be looking at a couple different sorting algorithms. We've got bubble sort and insertion sort. Let's get right into it. So to start off with, I'm going to show you the code and then show you what it actually looks like afterwards. So when you first open up the main.c++ file, you will find a few different functions. The first one being the generate random array. So what this is going to do is it's going to take in the array, the size of the array, and the range for the items inside the array. So what it's going to do is you're going to give it an array, tell it how many numbers you want inside of that, and then how big you want each number to be. So for in this case, I believe we used 100. So that means if we give it a size of 10, it's going to create 10 numbers in that array between the numbers 0 and 99 because of the range being 100. Same for 100, it will create 100 different numbers between 0 and 99, and the same for 1000. Then you've got the test sort function. This function is what's going to actually see how long it takes for the sort to happen. So it's going to take in the function that you're using to sort with, the array, and the size of the array. So for example, let's say you want to do the bubble sort. You'll tell it, hey, I want to test with sort bubble, the array, and then the size, which in this case it'll pick, which we'll get to that in a second, but it's going to use the clock, the high resolution clock, to allow for a lot more precise measurements. It'll start the clock, sort the function, and then end the clock. It's then going to display that. If you get down to the main function, this is where we set the different sizes that we have. So we created a array of data set sizes, so 10, 100, and 1000, and then you've got the range being 100. That is what will be used in the other functions. Then you've got the header for the table of results, so it's just a real simple to make it easier so you understand what's going on. Then the actual part that runs everything. So this is the loop, which we'll use. It'll go through the different sizes that we put up here in this array here. So for each one, so for the 10, the 100, and the 1000, it's going to run both sorts twice. So it'll generate the random array first. You know, for the 10 numbers, it will generate those, and then it will actually plug those numbers into the functions and run all of that, and then it's going to actually print out here what the results were. So it'll say bubble sort, how many you did, so if it's 10, it'll show 10, and then how long. And same for the insertion sort. It's going to run the insertion sort test, tell you how long it went, and it will loop that back through for each one. So it'll start with the 10, then go to the 100, and then the 1000, and once all of those are done, that is the completion of the code. You've got the bubble C++ file as well. This is what actually contains the functions for these. So the sort bubble function here, that's obviously for the bubble sort, and it's actually using this function up here, the swap function. So what the bubble function is going to do is it's going to go through each number in that array one at a time and compare the two numbers. If the second number is larger, it stays the same. If not, then it swaps it. And it'll go all the way through the list, continuously swapping the bigger number until it gets it, and then it'll go back to the beginning and continuously do that until every single number is where they're supposed to be. Now the sort insertion one, that one is actually going to start at the beginning. It's going to automatically assume that the first one is already sorted, and then it's going to take the second number and look at it and compare it to the first number. Okay, well, let's say we've got 23 is the first number and 12 is the second number. It's going to take that 12 and be like, okay, well, 12 is obviously smaller than 23, so it'll put that in the 23's place by moving the 23 over one spot and putting it there. It's then going to go to the third number and do the same thing. It'll compare it to the two that have already been sorted, and it's going to keep doing that until it gets to the end of the list. in doing so. So, I believe bubble.h, just so you can reference the actual functions, so they can be shown here in the main function, or yeah, the main file. Let's run the code. Okay, so when you run the code, this is what you're going to get. You're just going to get a simple table. Can't actually do anything in here. It does it all automatically. It's going to sort them and tell you the different times. In order to actually be able to tell which one's really fast, you can't just do it one time, because it can change. Usually not a whole lot, but I did go ahead and actually run the test 5 times for each one. So looking at the table, I was able actually to determine that at the smaller data set of 10, there really wasn't a whole lot of difference in the speed of them. So if you're doing something real small, it's not really going to matter too much between bubble sort and insertion sort. But as you start to get closer to higher numbers like 1,000, you can actually tell a difference between bubble sort and insertion sort, because bubble sort actually has a lot more to do as far as actually completing the sorting function, which is why it takes a little bit longer. Obviously not much that anybody can really actually notice, but if you start using even higher numbers, eventually you're going to start seeing a lot of performance differences. So in my opinion, insertion sort actually does a lot better job at performing a lot quicker, but that is just because it doesn't require as much work. I think that's all for now. Thank you guys for watching. See you next time.